Every Rust developer has hit this wall. You write code that makes perfect logical sense, and the compiler says no. Error 502 cannot borrow as mutable because it is also borrowed as immutable. What does that even mean? And more importantly, how do we fix it? Today we are taming the borrow checker, not fighting it, understanding it, because once you see what Rust is protecting you from, the fix become obvious. So let's dive in. Here's a function that seems perfectly logical. We have a refactor names. We want to remove any start with 0 underscore. So we iterate over the names using names.iter. This creates an immutable borrow. We are promising Rust will also read the data. But inside the loop, we call names.remove. That needs a mutable borrow. We are trying to modify the vector. And that's the conflict here. We have an immutable reference that's still alive, that is still alive. The iterator is still running, and we are asking for mutable reference at the same time. Rust says cannot borrow names as mutable because it is also borrowed as immutable. This is not a bug in Rust, it's Rust preventing a real bug. Modifying a collection while you are iterating over it would cause undefined behavior in C or C++. Let's visualize why. So let's visualize this and see. The immutable borrow from names.data lives for entire loop duration of for the loop. It doesn't end until the loop is done. But names.remove tries to make a mutable borrow inside that span. The two borrows overlap, and Rust fundamental rule is you can have many readers or one writer, but never both at the same time. So how do we fix this? The common fix: separate reading from writing into two distinct phases. Phase one: we read the data, we iterate, we filter, we collect the indices of items we want to remove all in one pass. This is an immutable borrow, and it ends with .collect finishes. Notice the borrow ends at .collect method. The data is now safely stored in toRemove function. No reference is being held anymore. Phase 2: we write, we iterate, we over our saved indices and reverse and remove each one. This is a fresh mutable borrow, no conflict. Look at the timeline now. The read phase ends completely before the write phase begins. No overlap. Though borrow checker is happy, it compiles. But there's an even cleaner way, which is solution B, the idiomatic Rust way, where we can use names.return. One line. It takes a closure, keeps every element where the closure returns true, and removes the rest. Internally retain handles the borrowing correctly. You don't have to think about it. This is the lesson. Whenever a standard library method does what you need, so just use that. Method like retain, drain filter, and deduct were designed specifically to avoid these borrow conflicts. But what if restructuring is not possible? What if your architecture demands that something be shared and mutated? Where it enters RefCell, it wraps your data in a container that enforces borrowing rules at runtime instead of compile time. Think of RefCell as a lockbox. The data is inside and you need to check it out. .borrow gives you shared read access. The box opens, you can look at the data. The other readers can look too. And borrow mutable gives you exclusive write access. Nobody else can read or write while you hold this. But if you try to do both at the same time, instead of compile error, you get a runtime panic and your program crashes. That's a trade-off. You are moving the safety check from compile time to runtime. The compiler cannot protect you anymore. It's on you. For single-threaded code, use RefCell. For multi-threaded code, use Arc with mutex. Same concept, but thread safe with locking overhead. The borrow checker is trying to help you. Interior mutability bypasses that help. Use it wisely as a last resort, not as an escape. So, when you hit a borrow checker error, here's your decision tree. Step 1. You got the error. Ask yourself, can I separate the reading and writing into two phases? If yes, use the phase pattern. Collect what you need first, then mutate. This is your best option. Zero cost, most common fix. If no, is there a standard library method like that handles retain, rent filter, or sort by? If yes, use that. Zero cost and it's the idiomatic Rust way. If no, do you need shared ownership, multiple parts of your code holding references to the same data? If yes, use RC with refcell for single-threaded or arc with mutex for multi-threaded. Be aware of the runtime cost. If none of the above, clone the data or restructure your ownership model. Sometimes a simple dot clone on small data is a pragmatic choice. Notice the pattern in the top two options, phase separation and standard methods are almost always the right answer. They are zero cost and compile time safe. So let's recap with a cheat sheet. Phase separation, read then write, it's zero cost. Standard methods, retain, drain, filter, zero cost. Clone the data for small data, simple fixes, just copy cost. Ref cell, single threaded, internal mutability, runtime checks. Arc mutex, multi-threaded, shared mutation, lock overhead. Understand the rules, work with the borrow checker, not against it. Now you know how to fix this error. So yeah, thank you.